All right, guys, welcome back to Lesson 11B, Day 1, Part 2, I guess is what we're going to call this. Today, you're still going to be able to find the sum or difference of rational numbers. You will still be able to discuss whether your estimates make sense, and you will still be able to use this for finding the rational distance between two objects. All right, so last time we went over decimal rules and making sure that we knew how to handle decimals, remembered our decimal rules for adding and subtracting. Today, as I said, day 2 with this lesson, we're going to be focused on fractions. So up here, you do see a little explanation on why we need common denominators with fractions. So we need to use the same unit. So if I start at 0 and wanted to add a half and then a third, it's a little bit hard to decide how much a third would be if I'm starting from the halfway point. So that's why we use common denominators. So we can split up a half. If we split up a half into 6 parts, so let's look at this. If we split up a half into 6 parts, then we would need 3/6 to equal that 1/2. And if I split up a third into 6 parts, we would need 2/6. So 3/6 plus 2/6, 1, 2, 3/6 plus the 2/6 that were there gives us 5/6. So we can see that broken up here. We can also see it on the number line here. But remember, with adding and subtracting fractions, we need to make common denominators. Common denominators. Write that down, please. Make common denominators. And so remember, the trick to that is looking for the bigger number and thinking of multiples of the bigger number until we get to one that would work for the smaller number as well. So let's look at number 8. I'm going to zoom us in. Here we go. Ah, don't fall. There we are. 1/8 minus 5/6. So here I see a subtraction, but remember in this unit we've now learned to rewrite all subtractions as add the opposite so that we know what we have more of. All right, in this case, we do have more of this number, but we can't quite tell yet until they have common denominators. So let's look at our denominators. We have an 8 and a 6. So let's think multiples of 8. I can't get to 8 from 6. 8 times 2 is 16, but I can't get there from 6. 8 times 3 is 24, and I can get to a 24 using 6. So let's rewrite this with 24ths. All right, so 24 was our number that would work for both of these. So 24ths, how did I get to 24 from 8? Well, I had to multiply by 3, and whatever I do to the bottom, we match up top. So that's going to be 3/24ths plus negative. Okay, how did I get to 24 from 6? Well, I multiplied by 4, and 5 times 4 is going to be 20. And so now I can see which one I have more of. I definitely have more of this one. And so that tells me I have more negatives. So we know already the answer here is going to be negative. The fact that I had more of something means I'm going to be subtracting these numbers. What did I have more of? Well, I had more negatives. I had 20 of them. And so we can focus just on these top numerators now that we know the denominator is the same. The denominator is going to stay 24. But the numerator is where we're actually doing that subtraction. So 20 take away 3 is going to give us 17. So we would have negative 17/24ths left over if we were to cancel out our additive inverses. And I can't reduce 17 by anything. 17 is a prime number, and so that's going to be our total answer. All right, so it's just like our fraction unit. We just threw in some negatives now. How about number 9? This one's fun. So I see a mixed number. Remember, we need to change to improper, so big by the bottom at the top. And so that's going to be, let's see, 1 times 8 is 8. Let's draw in those little circles. 1 times 8 is 8. 8 plus that 7 is going to be 15. So that's really negative 15/8 plus 3/4. Now that they're both, written as a numerator and a denominator, now we can make common denominators. So what's going to be common between these? Well, I'm going to look to the bigger number. The bigger number is 8. Can I get to 8 using a 4? Yes, I can. So let's use that common denominator of 8. I'm going to rewrite it over here just so that I have room. This is a plus. This is a negative. Looks like I got all those signs. I don't need to change this one because it's already 8, so I'm going to rewrite that negative 15/8. In order to get to 8s from the 4s, though, I'm going to multiply by 2. And 3 times 2 is 6. So now we can decide, what do we have more of? Do we have more negatives or more positives? And here we have more negatives. All right, so our answer is going to be negative something eighths. And how many more do I have? Well, from 15 to 6 means I have 9 more. So I have negative 9 eighths. That's now an improper fraction. So how many eighths can I take out of 9? I could take out 1. My answer, though, is negative. So this is a negative 1. Sorry, that's kind of scooched together. Let's fix that. Negative 1. And what would I have left up there? I'd have 1 left over up top. And if you needed to work that out, that's okay. 9 divided by 8, we would have 1, which would give us 8. We'd have 1 left over. Negative 1 and 1/8 is the answer there. Ooh, here's a good one. This one has both mixed numbers. Big by the bottom, add the top. That'd be 24. One more would make it 25 fourths. 25 fourths. I see minus and negative means add the opposite. So I'm going to write plus big by the bottom, add the top. Big by the bottom is 5, plus the top is 8 fifths. Now we are looking at 25 fourths plus 8 fifths. All right, we've got to make those common denominators because this is an addition problem. So let's rewrite that. Let's just write it next to it. This is just adding. Between 4 and 5, 5 is the bigger number. So let's think. We can't get to 5 from 4. So 5 times 2 is 10, but that doesn't work. 5 times 3 is 15, but that wouldn't work. 5 times 4 is 20. That would work. So let's use 20 as our denominator here. All right. To get to 20 from 4, I had to multiply by 5, so I do that to the top. And 5 quarters would give me 125. Over here, I had to multiply by 4, and so I do that to the top, and I get 32. All right. 125 plus 32. You could always work out to the side if you need to, but that's going to give us 157 over 20. And now we change it back to a mixed number, 157 over 20. By the way, I added because they're both positives, same sign, so we add. So let's see what we get from that. 157 divided by 20. Let's think. How many 20s can we take out? Well, let's think. Times 7 would give me 140. Times 8 would give me 160. So we're going to have to stick with that. 7 gives me 140. And we have 17 left over. So we would write this 7 and 17/20. There's our answer. All right, let's try a couple more. Number 11. No mixed numbers in this one, but I do see negatives. A negative plus a negative. So these are both negatives. I don't have more of one than the other because they're the same sign. So I'm going to end up adding them together just like it says. We do need to make some common denominators though. So negative something plus negative something else. All right, so let's see. Between 4 and 3, 4 times 2 is 8, can't get there. 4 times 3 is what we're going to have to use, so that's a 12. To get there from here, we multiply by 3, so we match that up top. We get negative 9/12 plus negative, this one I had to multiply by 4, and so I'll multiply by 4, and we get negative 8/12. All right, this is negative, that's some more negatives, so altogether I would have negative 17/12. Which I would rewrite as the mixed number, 1, and what would I have left up there? If I took out a group of 12, I'd have 5 left over. So that's negative 1 and 5/12. All right, let's try that again. We only have 2 more. Almost there. We can do this. Big by the bottom, add the top. This is negative 2 times 3 is 6, plus 2 more is 8/3. Plus negative big by the bottom would be 15, and the extra one would be 16 over 5. There we go, negative 8/3 plus 16/5. All right, let's make those common denominators. I'll write it down over here. It's negative plus a negative, so I'm going to write it that way to have it ready. Let's think of that denominator. So 5 times 2 is 10, can't get there from 3. 5 times 3 we can use. That's 15. So I can get to both of them, or I can use both of them to get to 15. To get there from 3, we had to multiply by 5, so we match that up top. We have negative 40. To get there from 5, I had to multiply by 3, match it up top, and that would be negative 48. All right, these are negatives. These are some more negatives, so we add them up, and we get negative 88/15. All right, that is an improper fraction, and so we need to divide to figure out what we've got here. So 88 divided by 15. How many groups of 15 can I take out of that? Well, 15 and 15 is 30. So 2 more would be another 30, so that'd be 60. 15 times 5 would be 75. 15 times 6 would be 90, so that's too much, so we're going to use the 5. That gave me 75. When I subtract, I have 13 left over, and so I would write this as the mixed number -5 and 13/15 left over. There we go. -5 and 13/15. All right, last one. 1 3/4 minus 2 1/7. Big by the bottom, add the top. This would be rewritten as 7/4. Minus big by the bottom, add the top would be rewritten as 14/15. Oh my gosh, what did I write over here? Did you catch that? I wrote 7/7. My goodness, there it is. 7/4 minus 15/7. Remember, this is a minus, so we add the opposite. And let's rewrite with some common denominators. All right, so let's think through our 7s. Let's think through our 7s. 7 times 2 is 14. We can't get there from 4. 7 times 3 is 21. Nope, so we're going to have to just go ahead and use 7 times 4, which is 28. So we can rewrite both of those with the common denominator of 28. We got there from the 4 by multiplying by 7. So up top, that would give me a 49. And on this side, we got there from the 7 by multiplying by 4. So up top, I would get -60. All right, so I know my denominator is going to be 28. But let's think up here. Do I have more positives or more negatives? Well, in this case, I have more negatives. So let's subtract. 60 take away 49 is going to give us 11. So I would have -11 left over, which means my answer is -11/28. That is a nice proper fraction. We don't have to change that one back to mixed. All right, so that's the whole trick. It's the same things we've been doing. It's just adding in the fraction rule of common denominators like we've been doing before. Make sure that you finish your exit ticket, and if you have questions or if you just want me to check, remember, I am here for you. I am at that back table. Come and ask me some questions. Have a great day. Yay, math!